Hey everyone, welcome back to our series on solving differential equations. This time, let's look at some simple application of differential equations. Let's say we are given this situation. We have a toy racket that consists of a casing and fuel. Initially, the total mass of the racket is 200 grams and the fuel is ignited at time equals 0 and then burns at the rate of dm over dt equal to negative 8t, where t is the time in seconds and it is greater than or equal to 0. And we are going to answer 3 questions. First, we would like to find the general solution of the given differential equation. Letter B, find the particular solution of the given differential equation that satisfies the initial condition that the mass is 200 grams and time equals 0 second. And letter C, when the fuel is exhausted, the residual mass of the racket casing is 100 grams. Find the time at which the fuel is exhausted. Now let's solve this problem together. So we are given this differential equation, dm over dt is equal to negative 8t. In letter A, we would like to find the general solution of the given differential equation. So we would like to find the value of the function m of t that satisfies this differential equation. So using our direct integration, we take the antiderivative of both sides of the equation. So the left side is the antiderivative of negative 8t dt. So our differential here is with respect to time. And the rate at which the mass decreases depends on the time in seconds. So simplifying, the left side is m. That is because antidifferentiation and differentiation are inverse operations. Then at the right side, the antiderivative of negative 8t dt is, we copy the negative 8, we apply the power rule. So we add 1 to the exponent of t. The implied exponent here is 1, so 1 plus 1 becomes 2. And we divide that by the same exponent 2 plus some arbitrary constant c. So this simplifies to m equals negative 4t squared plus c. So this is now the general solution of the differential equation. Sometimes you can see that the preferred way of writing this is to write this also as m equals c minus 4t squared. They're just the same, only that since you have a negative sign here, that can be rewritten as c minus 4t squared. So that's our answer for letter A. Now let's go to letter B. Find the particular solution of the differential equation that satisfies the initial condition m equals 200 when t is equal to 0. So all we have to do is substitute those initial values to m and t and solve for c. So our m is 200 equals c minus 4 times the value of t, which is 0, then raise it to the second power. So 200 is equal to c. And therefore, the particular solution given this initial condition is m equals, our c is 200 minus 4t squared. So this is our answer for letter B. Next, let's go to letter C. So for letter C, when the fuel is exhausted, the residual mass of the racket casing is 100 grams. So that means this m here is 100 equals 200 minus 4t squared. We are going to solve this for the time. So rearranging this, we have positive 4t squared is equal to 200 minus 100, which is 100. And so t squared is equal to 100 divided by 4, which is 25. And t is equal to plus or minus 5. But since we know that time is greater than or equal to 0, then we only accept time equals positive 5 seconds. So 5 seconds is the time when the fuel is exhausted. And that's how we apply solving differential equations by direct integration in this real-life situation. In the next video, we are going to talk about solving differential equations by separation of variables.